Enterprise Computing HSC course Unit 2, Data Visualization. So in the previous unit of data science, we established that we have data and it's quite complex. And then what we do then to make data more comprehensible to audiences and clients is we create visualizations. And we saw some of that starting to pop up in some of its subunits. This is now the unit focused on data visualization, essentially why we do it, tools we can use to do it, and how it helps us comprehend data as a part of our decision making process. By turning data into visualization, we can see trends and patterns, and that helps us make decisions for the benefit of our enterprise. So let's start off with the first subunit, that of using data to tell a story. And essentially, what is the purpose of data visualization? Well, firstly, to simplify information. As we say, a picture is worth a thousand words. I can have a whole range of data within a spreadsheet, all written within tables, but obviously I have to look into that spreadsheet and see information that is highlighted and really try to comprehend it. But then if I can turn that same spreadsheet table into a graph, suddenly things become a lot more simple for me to see. I can see kind of where data lies, who picked what data. It just makes it that bit easier to comprehend. So that's really how data can be used to simplify things through turning factual data into graphs and other illustrations that kind of summarize and make data a bit more readable to the less data literate people out there. We also use visualizations to tell a story. Once again, if I use the reference of a graph, the second I turn data into a line chart, we can see how data changes over time, and that itself can reflect trends and patterns. So data can tell a story if we give it the right visualization to support it, and then apply our own interpretations of those visualizations to the graph we've developed. And then with visualizations too, as well as tools we can use within tables, we can highlight results using conditional formatting. We can highlight results that are either concerning or pathways we can go that show that we are doing well. All of that can be highlighted within visualizations through the use of colors, shapes, and graphs once again. So there are many purposes to visualizations, but ultimately we can give data a narrative which we can apply our own perspective to in order to present to others and help them with their own decision making processes. The next area is software features for understanding data sets. And as said, I've done a lot of referring to spreadsheets. So spreadsheet has a variety of tools that can support data visualizations. Graphs, tables, pivot charts with splices, all of that can support the actual development of a visualization. But then as well, we can use presentation software to create visualizations and present them to an audience as well. We can have custom software generated for creating dashboards, which also can be created in spreadsheets as well. All of these software features help us create data visualizations that make data more interpretable to users. We then, within these visualizations, identify trends and patterns within data. And that's the ultimate goal of a visualization if we're going to use it for predictive reasons. If we can find trends and patterns in past data, data that may be stored in a data warehouse, that historical data, and we can kind of see when sales peak at a specific season or decisions that were made that made more buyers buy a specific product. If we can find those trends and patterns, well, then we can hopefully predict the future. And if we invest more into those certain areas, will that mean more profit in the future? All those ideas are made based on finding trends and patterns for us as an enterprise to capitalize on. Then we've got the evolution of technology supporting data analytics. And we have had many gains in technology that have allowed for greater processing. And if I link it back to the data science unit, one of those big areas of concern is that of big data, that we collect all this data, but then we've got to store it somewhere. Okay, we can get lots of data, but how do we store it? How do we make it accessible? And then, as you can see from the technology on this list too, the first one as well is processing power. Even with the coming of AI now, one of the biggest booming areas is that of CPU chips and getting specialized chips made, okay, for processing AI data. And that would support data that is stored in systems, okay, and stored potentially, as the second stage says, in our local storage or online storage in the cloud or in network storage, but then having to process those large amounts of data. And then we need the amount of RAM to support the processor if the data is live and we're doing complex calculations. And we create supercomputers for complicating large amounts of hard, difficult data to comprehend, such as weather prediction in areas like that. So we need the hardware technology to support whatever processing we are doing to create these visualizations and support us with our ideas in relation to data. So processing power obviously being a big one, storage and memory, both. So we're saying primary storage in RAM and secondary storage in our other servers we're using for storing data when at rest. Okay, they are paramount. But then the other area which I've also alluded to, as these systems are often networked as a part of an enterprise, is communications media. All right, the technology we're using as our nodes to connect our systems together, and then the actual mediums we're using to connect those nodes, whether they be wired in the use of optic fiber cabling or the use of radio and microwave wireless mediums to connect our network together, and using the existing telecommunications infrastructure that might be available through 5G. All of that technology advancements supports the speed of data transfer over our network as well. So we've needed these advancements, and these advancements will continue to happen if we hope for this area to grow and support our analytics of the data we're creating. We've then got data integrity. So this is basically ensuring that data is accurate and correct, but also follows very specific rules to support that, okay, and give us meaning to what we are using it for. So with data integrity, we've got to look at who owns specific data. We might be pulling in data from another source or getting the data ourselves, but we've got to declare that, and it can become very grey when we are interacting with other parties, and basically establishing what is the source of this data. Is it reliable? And that's paramount to data integrity, because if we're getting data from an unreliable source, the data is ultimately going to be incorrect and mess up our calculations when we use it for our processes. So we need to get it from a reliable source and do cross-referencing so we have multiple sources supporting a specific idea or path of action that we are planning on going for. To support data upon entry going to a system being correct, we need to use validation tools. Validation tools can make use of drop-down menus or date and range checks and data type checks that can ensure that data goes into a system correctly, because a simple typo can make data incorrect. So we need to have as many rules as in place to validate, and this can also be supported by verification techniques as well, where we kind of see a copy of the data prior to us finally executing and entering it into the system too. And then obviously the risk associated with data, and what it's about and how we are using it as well. These are all factors that need to be considered as a part of data integrity. Here, as mentioned before, is big data. The fact that we've got lots and lots of data, we struggle with where to store it. It is fantastic as a data source, because the more data we have, the more data we have to refer to, but we've got to factor it into how we're storing it within our system. Here, within the big data too, we've got to think, what is the scope of information? Is it relevant to many topics or one topic in specific, or how are we categorizing it? And then what are the types and depth of insight we can extract from this big data? So we've got to find a way to arrange it both on our software and in our databases or in our spreadsheets, but also the mediums backing it up as well. That's all got to be thought out in order to support those areas. And then we've got bias. Okay, bias being a very tricky factor, and I'll actually start with the bottom one on that sub list. Bias is not always intentional. Essentially, bias means that we're not getting a wide enough scope in the data we are collecting, and it can lead to data being skewed to outcomes that aren't actually correct or reflect a specific target audience. So we need to do those things and make sure we get a balanced amount of data from a variety of sources in order to ensure that data is firstly accurate. We've got enough data from many different varieties of sources to ensure that it is correct, and a wide enough audience to ensure that it is correct, getting all their different perspectives on what it is about. Data sources might also be at a lot of levels. So it might be on customers, it might be from team members, it might be from other people within an industry we are looking at and getting their feedback. So we need a variety of sources as well to paint the full picture of whatever we're developing too. And I use the word picture specifically because we're talking about data visualizations. Because if we could create a data visualization, it's very easy to make an incorrect visualization that can be used to mislead or provide information that is not correct. So we've got to be clear on there, and bias is a big factor in all this that we've got to address. We then got the use of OLAP tools, and OLAP tools are often used for analyzing data for data mining. This can be on data stored in databases and also very likely used in conjunction with a data warehouse. Data warehouses being where lots of archived data is stored with a historical use. So there is the data warehouse there. So we store the actual historical data in a data warehouse. So this could be data from previous years. Okay, so we could have like a section for each previous year of business that we have done, and we store it in the warehouse. Then we want to correlate that with current data. So we'd use OLAP tools to analyze that and see kind of, once again, what are the trends and patterns. And this can help us with our decision making processes for the current year. And then we have tools available within the warehouse for refining data or optimizing data, and once said, used in conjunction with OLAP so that we can look at data in a variety of perspectives to suit the needs of what we want to do. The next area then is interpreting data visualization. So we can see the visualization now. What are we going to do with that knowledge? So firstly, it is the software tools we can use now to kind of set up these visualizations. As mentioned before, with spreadsheets, we can create those dashboards. And I kind of said in the previous unit, that could be a way you go with an assessment task to kind of assess both this unit and the previous unit. All right, that you set up those dashboards where you kind of get rid of the grid look. Okay, your data might all be on a separate spreadsheet, but then you have a different sheet that isn't actually a sheet. It's got a graph, it's got a pivot table, and it's got a splicer on the side. And then as you're clicking on different things and changing values, the actual graphs are changing live in front of you. You can see how it's responding to different data. That kind of tools are available within spreadsheets. We've also then got presentations used for when someone is presenting to an audience so they can talk about the statistics and give their audience a very clear overview of how the company is going, okay, by showing the actual visualization and actually showing the people who don't understand data as well or don't have the time to look at the data in detail. We're really summarizing it with a presentation with visualizations reflecting what is the current state of things to come. This obviously correlates in many enterprises with business analytics. Okay, so actually having the business data in there, that being the thing that is being comprehended, and there are services available for supporting that. And then we can also look at custom software generated from the ground up to support developing visualizations for delivery to audiences. The next area is then interrogating data from visualizations. So actually interrogating what you see on the actual diagrams, okay, on the graphs, the charts, whatever you're looking at. Okay, what do you interpret from that? How do you interpret it? So you're looking at it with a lens relating to whatever topic you are looking at. We then talk about aggregation because data builds up over time. And then how does data change over time? Okay, with that build up. That's a factor in our understanding of data. We also then need to filter data into its subcategories, and that's why we talk about pivot tables so much in this unit, because we understand that there can be multiple categories of data, but we can switch them on and off so that we can focus on specific categories of data and specialize and target specific areas for our goals within an enterprise. We have to also factor in outliers, those elements of data that are not consistent with the trends and patterns we are seeing. Why are they the case? Is there a reason behind it? And we've got to determine that. And then that final point correlates with that as well as in relation to all the points above. The reasoning potentially behind the data we are seeing, our own interpretations in order to fully understand the visualization we are looking at. The third area is then designing for user experience. We're in this unit talking about digesting data, complex information into a visual form to support people's understanding. Thus, designing for user experience is paramount because we want people who access our systems to be able to view the data with ease and understand it with ease so that the data meets their needs. So here we need to look at graphic design tools. What software are we using to actually build the GUI of what we're developing? All right, and will that assist in the comprehension of our users when they access our system or the participants of our system in comprehending information? So design tools that allow us to create everything, the buttons, the shapes, the graphs, all of that, to create it in a way that not only reflects information but potentially our own corporate branding as well, okay, and gives a whole look and feel to the system we have developed. The next area related to it is the actual influence of user experience. People in many cases might not care about the data they're seeing. If it's related to government information, there are many people that can switch off straight away and be like, I don't really care. I don't really want to know about it. They've already got their own established biases on what they want to do. So we have to use user experience and its influence to build relevance to the audience. Why should you vote for a different party this time around in the upcoming election? And really try to use the data visualizations to show, well, look what the current government has done. Look what the potential next government could do. Or why you shouldn't vote in a new government. This is what their plans are. This is how it's going to impact them. Once again, people aren't wanting to see numbers on screen. They want to see summaries of information and diagrams, things that make it more meaningful and relevant to the specific audience. From there, the audience will interpret that information and make decisions based on that. So, user experience is a powerful tool because you can really guide people's decision making, especially at a public level, like when it is relation to government. So, you'll see media sources and you'll see biases everywhere. Unfortunately, it is a part of real media, social media, all of that. Everyone is pushing their agendas, okay? And user experience has an influence on that. If you enjoy using something and they're telling you this is the way to go, you could potentially support it just for that reason. As a part of user experience too, customization is a major factor, even as simple as the ability just to make text bigger and smaller, or other tools as well, such as voice to speech or text to speech for what's on screen to read information out to an individual, the ability to change sizes of things on screen or change the type of diagrams you're looking at for a same data set. All of that will impact on the user's experience when interacting with data and support their comprehension. And then that final point of live analysis. The data is updating live. You're seeing a live version of the data that is being presented on screen. So it's not from a week ago, it's not even from yesterday. You are seeing what's happening now. And a big area where that is so important is that of the stock market. Where are the stocks at right now? Oh, look what's happening right now. We can see something's dipping. Quickly sell, sell, sell. Live data analysis is extremely important, especially when it's tied to people's financials or ways of life. We need that live support there. So user experience is extremely paramount in relation to our systems and the visualizations it provides. The next area is the criteria for evaluating user experience. So how do we know the system is working well for our clients and our users that are interacting with it? So interviews and surveys, they can all really support us gathering data about how users are going, getting data from the people we're interacting with there, and not just do they like it or don't they, but getting that open and constructive criticism too, so that we can then modify and perfect the system that we have created. We also have emerging technology, not just impacting on user experience, but also on the user interfaces we're developing too. We could very well, in a few years' time, be looking at all this data and information with a VR headset on our head. Well, VR headsets, they're not mouse and keyboard. That's completely different to what I'm doing right now in order to look at specific data sets. There, I'm moving my head, and there's an accelerometer in the VR headset, so it's actually moving with my movement. And these days as well, they're using eye trackers to see what I'm looking at, and I'm clicking my fingers together to execute. So technology is changing, and that changes how we are interacting with data. And thus, the visualizations must be made in a way so they can interact with new types of hardware. And then also, as said before, we already talked about technology evolution for analyzing data. The processing power of CPUs increasing, the amounts of RAM increasing, the use of online storage increasing the capacity of how much we can save, and then network infrastructure and communications, media, and central nodes. All of them impact on how large we can make networks as well, and how big we can make our platforms for people to access and view our data. So these are all factors that we need to consider for developing our system, developing our user interfaces for interaction, and the power behind them to support that user experience. The final area is that of creating data visualizations. And once again, here I'm going to highlight a few points that could correlate with assessment tasks that you might do at school. So first area is that of we've got to research, source, organize, and store data. Okay, data has to, as said, come from reliable sources. And we've got to cross-reference in order to do that to make sure the data we are getting is correct. Otherwise, that's going to mess up our visualizations and we're not going to get an appropriate reflection of trends and patterns going on. So we need to research them and source them and cross-reference them. We then have to organize data in a way that's going to make an appropriate visualization, order it, categorize it, and sort it and filter it so we get the right visualization there. And then we need to store data, whether it be on our own local servers or on online cloud storage, up to us to decide as a part of our enterprise. The next area is designing and developing a visualization for a specific scenario. So this is straight from the syllabus, and this could be the basis of what you do as a part of an assessment task. So it could be that you are, as said in the previous unit, creating a dashboard, okay, that is responsive and shows things such as trends, patterns, and relationships, okay, related to a specific data set that you are researching. By showing those things in your visualizations, you can make predictive analysis and then say, well, this is the course of action that this company or business should go. And a major part of this data source is to interact with a big data source. And we'll see what's out there and what's available. There might be government data available in order to do this, or some stock data making it. It's up to your school to decide how they address that. But then that is one clear thing you have to do as a practical activity as a part of this unit. And then the final area is maintaining data security. If we picked up on one thing in this unit is we're looking at a lot of data, a lot of big data, okay? But big data, okay, it is obviously private in many cases, okay? So we need to keep it secure, especially when big data relates to people's personal information and obviously their financial information, their medical information, that personally identifiable information, which is sensitive to people in many cases. And obviously there's laws on protecting it, the Privacy Act 1988. Data must be kept secure. So data is valuable and we do need it for our decision making processes, and we do want to visualize it so people understand it, but we've still got to protect those areas relation to data. And then key areas of security that need to be maintained is firstly that of cybersecurity threats. Okay, people, when they know there's a lot of meaningful data somewhere, they're going to try to hack it and get it. So we need security procedures in place, login procedures, firewalls, encryption, two-factor authentication. Okay, all of that needs to be set up to protect the data from people obtaining it and ruining it. But then also data backup procedures, which is also a procedure that protects us from hackers, but even from our own error and things that can go place in our own enterprise, just hard drives being destroyed or failing. We need to have backup procedures in place as well to protect data from essentially its loss or becoming inaccessible to us. So we need to plan for that element in relation to data too in our enterprise. So I hope this video has given you an understanding of data visualization. The whole purpose here is we've got all this data. We need to simplify it, digest it, and output it in a way in a visualization, such as a graph, a dashboard, a table, a chart, or some sort of combination of them all being used together, which is more likely, that makes it more understandable to end users, to clients, to stakeholders, and supports their own information and decision making process. So it is a very important unit because there's heaps of data. We are in an age where we have access to more data than any previous generation. We've got automated systems collecting data for us and just getting it from many different sources. But we need to obviously then categorize the data in a way that makes it meaningful and comprehensible. So that is what this unit is all about. Obviously, we need to make our visualizations targeted towards a specific user experience that correlates with our enterprise so that people will want to keep viewing data through our outlet of our enterprise. Okay, and it gives a satisfaction and also creates relevance to why people would want to understand this information. We need to meet our audience needs in this area and hopefully grow our audience through making effective data visualizations that people can understand. And this will ultimately expand our enterprises. And with these visualizations too, they show how things are going. But when we can find those trends and patterns, it helps us with predictive analysis and hopefully plan our enterprise's future, the decisions being made, where we should be spending money, okay, what changes need to be made, so that ultimately we can find the most successful path forward for our enterprise. So obviously, data visualization, it is so important in this day and age.